Hello, curious minds. Did you know that this month, Earth will have a second moon? Well, almost. For the next few weeks, a tiny asteroid will be caught in Earth's gravitational pull, becoming what we call a mini-moon. It won't be as big or bright as our natural moon, but it's still an incredible phenomenon. Want to know how this happens and why we can't see it? Stick around to learn all about Earth's fleeting second companion. Let's get to know our mini-moon a little better. 2024. PT5 is not a threat to our planet. It's a small, harmless object orbiting the sun. Asteroids are like leftover building blocks from the early solar system. It's been traveling through space for billions of years. Now it's making a brief appearance in Earth's neighborhood. This phenomenon will occur between September 29th and November 25th, 2024. During this fascinating 56-day period, this mini-moon will enter our planet's gravitational pull, tracing a unique horseshoe-shaped trajectory. It's important to note that while this little rock may not light up our night sky like the moon we know, its visit offers us an incredible opportunity to observe how celestial dynamics work in our solar system. So, what exactly is this intriguing object, 2024 PT5, discovered on August 7, 2024, by NASA's Asteroid Terrestrial Impact Last Alert System, or ATLAS? This asteroid is quite small, just 10 meters or 33 feet wide. To put that in perspective, it's roughly the size of a school bus. But don't let its size fool you. 2024 PT5 is part of a special group of space rocks known as near-Earth objects or NEOs. These objects orbit the sun just like planets, but, occasionally, they come close enough to Earth to be influenced by its gravitational pull. Interestingly, scientists believe it originated from the Arjuna asteroid belt. We'll talk about that later. Now we've been calling 2024 PT5 a mini-moon. But what exactly does that mean? It's a bit different from our regular moon. Our moon is a large, permanent satellite that orbits Earth. It's been with us for billions of years. Mini-moons, on the other hand, are much smaller than our moon, which has a diameter of 3,474 kilometers, or 2,159 miles. And they don't stick around for long. They're asteroids that get captured by Earth's gravity, and their low velocity makes them easier to trap, at least for a short time. These mini-moons don't orbit in the same way as our moon. Their paths are usually more erratic and unpredictable. They're influenced by the gravity of both Earth and the sun, creating a cosmic tug-of-war. Now let's dive into one of the most fascinating aspects of 2024 PT5, its orbital path. It will trace a horseshoe-shaped trajectory as it temporarily becomes Earth's mini-moon. When 2024 PT5 enters Earth's gravitational pull around September 29, 2024, it won't fully orbit our planet like the moon. This gravitational tug disrupts. The asteroid will loop around Earth in a curved path, but instead of completing a full circle, it will eventually reverse direction and head back toward the sun. But why does it follow this unusual path? Well, it's all due to its low velocity and close approach to Earth. When 2024 PT5 gets close enough to Earth, around 4.5 million kilometers or 2.8 million miles away, our planet's gravity will influence its motion, pulling it into this temporary orbit. However, because the asteroid isn't moving fast enough to maintain a complete orbit, its path shifts, creating the distinctive horseshoe pattern. So, why can't we see it? Well, the answer lies in its size and brightness. 2024 PT5 is incredibly small, measuring just 10 meters or 33 feet wide. In contrast, our moon is 3,474 kilometers or 2,159 miles in diameter. This makes 2024 PT5 far too tiny to reflect enough sunlight for us to see it with the naked eye, or even with most amateur telescopes. Another reason we can't see it is its low brightness, or absolute magnitude. 2024 PT5 has an absolute magnitude of 22, which means it's too dim to be observed even through most backyard telescopes or binoculars. In astronomy, magnitude is a measure of a star's or other celestial body's brightness as seen by the human eye. For context, the brightest stars we see in the night sky have magnitudes of 1 or 2, and they can be seen without a telescope. Moreover, 2024 PT5 will be traveling millions of miles away from Earth, at a distance of around 4.5 million kilometers or 2.8 million miles. That's about 12 times the distance between Earth and the Moon, making it even harder to spot. So while it's fascinating to know that Earth is getting a second mini-moon, its small size, dim brightness, and distant location all combine to make it invisible to us without professional-grade equipment. Even though we won't be able to see it, scientists will be closely monitoring 2024 PT5 as it makes its brief visit to Earth. Now that we know what 2024 PT5 is, let's explore where it came from. Scientists believe that this small asteroid originated from a special group of space rocks known as the Arjuna asteroids. The Arjuna asteroids are a group of near-Earth objects, or NEOs, that follow Earth-like orbits around the Sun. This means their paths around the Sun are relatively calm and similar to our planet's orbit. These asteroids typically travel at low speeds and at a distance of around 150 million kilometers, or 93 million miles from the Sun, about the same as Earth's average distance from our star. Because these space rocks share such a close orbital path with Earth, they sometimes come near enough to be temporarily influenced by our planet's gravity. That's exactly what's happening with 2024 PT5. So what happens to 2024 PT5 after its brief stay in Earth's orbit? As we know, this mini-moon isn't here to stay forever. On November 25, 2024, this asteroid will reach the end of its temporary visit and escape Earth's gravitational influence. Once it exits Earth's gravity, the asteroid will resume its original path around the Sun, following an orbit similar to Earth's, but no longer influenced by our planet's gravity. It will go back to being a regular near-Earth object, continuing its long journey through space. What's interesting is that this won't be the last time we hear about 2024 PT5. Like other Arjuna asteroids, which often have orbits similar to Earth's, it is expected to pass by our planet again in the future. Scientists predict that it could return in 2055 and perhaps even become a mini-moon once more. But until then, it will continue orbiting the Sun as part of the wider population of near-Earth objects. While 2024 PT5 may be making headlines as Earth's newest mini-moon, it's certainly not the first. In fact, Earth has had several temporary moons in the past, small asteroids that get caught in our planet's gravitational pull for a short time before continuing their journey around the Sun. The first known mini-moon was called 1991 VG. It arrived in late 1991 and left in early 1992, and like 2024 PT5, it was around 10 meters in diameter. One of the most well-known examples is 2006 RH120, a small asteroid about 10 feet, 3 meters wide. It was temporarily captured by Earth's gravity in 2006, becoming a mini-moon for about a year before it broke free and returned to its solar orbit. Another fascinating case is 2020 CD3, which was discovered in 2019. This mini-moon, measuring around 2 to 3.5 meters or 6 to 12 feet in diameter, orbited Earth for roughly 3 years before it escaped in 2020. It too followed a chaotic path, looping around the Earth in an irregular orbit. These mini-moons tend to be small, usually no larger than a car or a small bus. Their orbits are unstable due to their size and speed, which means they can only remain around Earth for a short period of time before they either drift away or burn up in Earth's atmosphere. The study of mini-moons like 2024 PT5 provides valuable insights into near-Earth objects, NEOs, helping scientists learn more about their origins, compositions, and potential impacts on Earth. So how do scientists study mini-moons? They use a combination of ground-based and space-based telescopes to track their paths, analyze their physical properties, and predict their future trajectories. This data can reveal important information about the asteroid's size, shape, and surface characteristics. Additionally, researchers monitor the gravitational interactions between these asteroids and Earth. By understanding how these objects behave in our gravitational field, scientists can gain insights into the history and evolution of our solar system. In conclusion, while 2024 PT5 may be a fleeting visitor, it serves as a reminder of the dynamic relationship between Earth and its cosmic neighbors. As we continue to explore the universe, we can appreciate how even the smallest objects can contribute to our understanding of the vastness around us. If you enjoyed learning about Earth's temporary second moon, make sure to like, subscribe, and share with fellow space enthusiasts. And here's something to think about. If Earth could capture asteroids like 2024 PT5 more often, what do you think would happen if we had more than one moon for good? How might that change life on our planet? Let me know your thoughts in the comments below. Thanks for watching. Until next time, keep looking up.